Hello traders, boy oh boy do I have a crazy fascinating video for you guys today. This is going to be very different than my normal, and without revealing it, let's just dive right in. So about 2 days ago, I watched this documentary, which I'm going to post a link in the description below, called Connected. And it was, I think, episode 4 just on numbers or something. And a lot of people who research Benford's law come from that Netflix documentary. And I was just like pretty blown away at this concept. So let's just introduce what this theory is, and I'll show you why it's used in crypto and why you can use it in crypto for some pretty cool applications. So this may seem really unbelievable, but if you take any set of numbers, I don't care if it's like a bunch of whatever numbers you have. Typically, what you're going to find is that in that data set, 1 will be the leading digit in a genuine set of numbers 30% of the time. 2 will be a leading digit 17.6% of the time, and yada yada yada. So this is frequency. Typically, you would expect here that if the digits were just uniform and random, then the leading digit should just be 11.1%. Because if we have digits from 1 to 9, wouldn't you just expect that? But no, actually 30% of the time, 1 is the first digit. So here you might be saying, okay, why does that matter? Who cares about 1 being the first digit? If that's true, which you might be like, all right, I don't even know if that's true, but if that is true, why would that help me in any case? Well, look here. This might begin to blow you guys away. So right now, this is BTC perp from FTX on the 1 hour time frame. Look at the blue is the actual and the red is Benford's law. So what we can see here is, look at this. This measured every single candlestick and the percent change from every single candlestick. And what I found was that every single one of these main cryptocurrencies has the exact same distribution as Benford's law. Look at this. So we can see that on average, if you remember, 1 should be the leading digit about 30% of the time. It's the leading digit 29.25% of the time for BTC perp. 2 should be about 17%. It's 18% here. 3 should be, I think it was like 12.6. It's 13% here. So if you're wondering, well, how do we get these? Well, what it does is each one of these yellow things that you're seeing right here, if you look here, you can see their values. These yellow things are saying, hey, what was the leading digit? And then in blue, you can see what was the percent change. So here on this 1 hour candlestick, there was a 1.1% change down. The leading digit will be 1, right? Now here, we can see a 0.3% change down. The leading digit is 3 because there's no 0 leading digits that Benford's law uses. Okay, I know this sounds insane, and even saying this out loud kind of sounds crazy, kind of like another, Fibonacci, whatever. Okay, Fibonacci's are cool too, but this is something that's pretty important for one thing that you might not expect at all: fraud. So actually, if you were to go look up Benford's law right now, you were to pause this video and then go search Benford's law, you're going to see a lot Benford's law uses. A lot of people who use it actually use it for detecting tax frauds, for detecting crime, because for detecting voter fraud even, whenever you see a massive deviation from Benford's law, let's say that the data set you have massively deviates from Benford's law, that can indicate manipulation and fraud. Yeah. So what I've thought is, what if we were to look at a bunch of coins on the 1 hour time frame? What if some coins really deviate from Benford's law? That could very likely be that those coins are actually manipulated, because they're not following the distribution that nearly every single non-manipulated currency should. So look at this. Let's go to FUSD Coinbase and let's see what it is on the 1 hour. It will pop up. So you can see it follows Benford's law pretty well too. The actual is just a little bit under for the 1. You can see that its 1s occur a little less often. Let's do Link. Sure. Link USD. I'll do it from Binance this time. Let's do... Also, you can't do this with Bitcoin, with things traded to Bitcoin. Only do this with USD and USDT. So if you use Benford's law, just remember to just use it to Link USD or BTC USD, not Link BTC. Okay, so let's do Link USDT from Binance. So we can see, does this follow Benford's law? Yeah, this does follow Benford's law pretty accurately. The only massive deviations I see is that the leading digit isn't 2 or 3 as much. And we also have something weird here. This doesn't indicate like extreme manipulation, but there is something a little bit weird going on with Link. Yeah. let's go to the 1 minute just for kicks and giggles. Oh yeah, that is quite the deviation from Benford's law. We have, okay, so this is a data set of 26,910 1-minute candles, right? And you guys know what it does. It parses the leading digit of each candle, right? Percent change of each candle, the leading digit of that. And we can see that ones occur a lot more often. This just looks a bit strange, but this could just be because of variance of the 1 minute time frame. How about the 5 minute on Link? Because this is a bit, oh yeah, and we have even more variance. So I didn't actually do any research on Link and Benford's law, but this is actually indicating to me, guys, that Link seems to be more manipulated than not. Weirdly enough, like, I mean, this is not like some joke or spoof. I'm actually telling you guys that this is deviating from Benford's law a lot. And if I look at something like LTC, perp, you know, I will bet you, oh, well, this one deviates a little bit from Benford's law too. Maybe I'm uncovering some, you know, manipulation thing that the market makers don't want you to know about or something. Oh, God. What is that? What is this massive, weird deviation from Benford's law? What I'm looking at, and what I mean by deviation, is reading it here and looking at the visual. Whenever you see the blue line just very different than the red line, that indicates that the frequency of distribution of the first leading digit is very different, which can indicate potential foul play. Again, some reasons why we might see some weird deviations from Benford's law is this. If something's really illiquid, it's not really going to give us great data. So, of course, it's going to deviate a lot from Benford's law if it's not liquid. I mean, duh. Another reason is on lower time frames, there's just more noise sometimes. So you might want to only use this for like 1 hour and up, to be honest with you. But well, here's a coin that I found that I think might actually be kind of manipulated. Oh, no. This one's actually one of the more accurate. No, this one almost exactly follows Benford's law. Look at this. It follows ones to like a T. It follows 2 to like a T, 3 to 2. Yeah, like this one's like really, really clean. So what I'm really looking at here, and you guys can use this indicator as well. You just have to do this, hit that, and then type in Benford, and then you get it right there from Grant Peace. What I'm doing here is I'm parsing through all these different cryptocurrencies to see, hey, does the distribution of the first leading digit really deviate? And if you think that I'm like crazy or something, maybe I am, but go look up Benford's law and famous use cases like I had said before. It has been used to detect fraud in voting. Because when you see it was like the data of votes, typically it should be following Benford's law, but when you see massive deviation, that can show foul play. And that's why I'm obsessing over this for this episode on my YouTube channel, is I think that it's really, really cool that I can put in any cryptocurrency and can see if the leading digit follows Benford's law. You also want this sample size to be really, 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 really high. Like 1529 is nothing, but if I go to like the 5 minute time frame, which I know might have more noise, but it's got a lot bigger of a sample size. If I go to the 15 minute, 5,918, and it's not really following. It's kind of following Benford's law. The shape is almost always the same, and the shape is almost always the same because the leading digit will almost always be 1, 2, or 3, and it's a lot less likely that the leading digit's going to be 9. Because if you look at this right here, guys, 30.1% of the time the leading digit should be 1, 17.6% of the time it should be 2, 3 about 12.5, and you can see how these numbers contrast with these. The leading digit will be 9 only 4.6% of the time by Benford's law. And this is just a pattern to the universe that I've recently discovered, and I was just like, I gotta share this with the YouTube community to see, you know, how they respond to it. I'm either gonna get like a lot of people calling me tinfoil hat, or people are gonna be like, oh my gosh, this is a great way to detect pump and dumps, to detect like fraud in different cryptocurrencies, you know? So something like that's on near everyone's mind. Let's go to Uni USD. But I want one with a lot of data, of course. Let's go to the 15-minute. Not that much data, but look at that. Even with 1456 candles, there it's kind of ugly. But if you look at there it's kind of like, what? But 15-minute, it's like near perfect following Benford's law. Now, the really weird thing about Benford's law that I also found was if I type in like a random time frame, like 46 minutes, it tends to follow Benford's law as well, and I'll show that to you guys. I know this might not be a great example, but if I go to Coinbase and go to the 46-minute time frame, it typically tends to follow Benford's law. If I go to like the 783-minute time frame, the distribution of percent change for each one of these 783-minute periods tends to follow Benford's law. If I do like today, it tends to follow Benford's law even when there's less data. So the use case for this in crypto is probably even more than what I've been saying today. For me, I just think it's really cool to detect if something's, completely just being manipulated or not. But maybe you guys in the comments can think of some other really cool ways to apply Benford's law. And if you want to know more about Benford's law, Google it, go on Wikipedia, watch the episode that I'm going to link below if you have a Netflix account. Because I think that there's more to this than meets the eye. And I think that the cryptocurrency community really likes Fibonacci and that pattern of numbers that sees itself in nature. And I think that the next progression of that will be Benford's law. That a lot of people will be using this to detect if something is fraudulent or not. So with that, happy trading. Start plugging in any data distribution set you have ever and see if it follows Benford's law. Okay? I'll see you guys next time.